Thank you everybody for coming. I'm Radoslav Albrecht, I'm the founder and CEO of Bitbond, and we are very happy to host this satellite event at Tech Open Air this year again. It's our third satellite event. This is definitely the one with the highest attendance, and actually Tech Open Air confirmed that this is the most popular satellite event, so thank you all very much for being here and being interested in this topic. At Bitbond, we have been using blockchain technology for 4 years now in production, which is relatively rare. We are also one of the very few licensed financial services providers that is using blockchain technology. So we know the technology side as well as the regulatory side very well. And as we use the technology, we obviously observe new developments and evolutions in the space and look which of the new applications that are coming up we can use for our purposes. And today we want to use some of the knowledge and share it with you, and we hope that you will learn a lot. And so let's get started about blockchain smart contracts. So there are 3 parts of the presentation today. First is like a primer on blockchain technology, because it makes sense to have a bit of a background knowledge in order to understand smart contracts, to understand a bit of a background about blockchain technology. Then the second part is some basic introductions into smart contracts. What are they? How do they work in general? And then in the third part, we will be looking at some use cases and what are actually interesting applications of smart contracts. And so let's jump right in. Let's see if this works now. Oh, Tom, if you could help me. Okay, thank you. Perfect. So let's start with blockchain technology. And first of all, why is this actually an interesting technology, and why should we be talking about it and being interested in it? Well, generally there are two reasons for this. One reason is that you can do existing applications within financial services and in other industries that are more efficient than if you don't use blockchain, but if you use other more conventional technologies. And then the second reason is that you can build new applications that would not be possible without blockchain. Bitbond is actually one of them. We do cross-border lending, where people can lend and borrow money from each other across the world, across borders, and this is something that would not be possible without blockchain. And one more, please. So how did blockchain actually start, and where does the technology come from? The original goal was to create digital cash. The inventor of Bitcoin wanted to create digital cash. And the reason why many inventors before him failed in creating digital cash is that when you have digital assets, they are inflationary. Digital assets do not know the concept of scarcity. If you take an MP3 file, if you take an image file, then you can copy them infinitely, and therefore they are not scarce, and therefore they don't serve well as cash, because they are not a good store of value. And this is a problem that many people before Satoshi Nakomoto, the inventor of Bitcoin, ran into, and Satoshi Nakomoto was the first one to actually solve this problem. Now, how did he solve it? He invented the blockchain, which is a distributed public ledger. Now, what does that mean? A distributed public ledger is a ledger of transactions that, first of all, is public, so everybody can have a look into that ledger. And second, it's distributed, which means that there are many hundreds or even thousands of copies of that. And now, why does this solve the double spending problem, the aspect of non-scarcity in digital assets? Well, imagine you have an account balance on an account, and accounts in the Bitcoin world or in the world of digital currencies are actually called addresses. But it's really a very similar concept compared to a bank account number that you may know. Now, if you have a certain balance on your address and you spend that balance, you send it somewhere else, and then you try to spend money that you actually don't own, which is not in your account anymore, then nobody will be accepting that transaction, because they can see publicly that the address you're trying to send money from doesn't actually have this balance anymore. And that's the clue, and that's the big sort of innovation around blockchain. Now, The distributed aspect is also something that's very important. And on this slide, you can see nodes on the Bitcoin blockchain. And there's actually over 7,000 nodes worldwide. And each of these nodes stores a full copy of the Bitcoin blockchain, meaning that it has a full history of the transactions in the Bitcoin blockchain. And if you wanted to change the history, if you, for example, wanted to create money that actually doesn't exist, you would need to change all 7,000 copies of the Bitcoin blockchain. And it's something that's nearly impossible, or only possible at extremely high cost. And therefore, it's a very safe method to store transactional data. Now, besides storing transactions in blockchains, there's also one other thing that they can do. You can store something that's called metadata with each and every transaction. So when you send a Bitcoin, for example, you can also attach more information to that. And in this case, it's called a colored coin, because you attach certain characteristics to that coin, and they let you do something. You can either use it as a simple messaging service, so you could just say, "Hello John, how are you?" You could have that coin represent something else in the real world, like a piece of land, or a share of a stock corporation, or any other real asset could be represented by that token, and you could transfer ownership of that asset via the blockchain just as easily and just as securely as you can do that with the Bitcoin token or the other digital currencies that exist. And then the third thing that you can do with that metadata, and that's something that's highly relevant for our presentation here today, is that you can also run code and execute code on that blockchain. And what that actually means, we will see throughout the presentation. Everything started with Bitcoin, as I said, because Bitcoin was basically the first invention of the blockchain. Now, Bitcoin was primarily created to represent digital cash. As I said, it solved the double spending problem, and it was invented in order to send payments through the internet, across borders, really fast, and at really low cost. Now, smart contracts is something that is possible on the Bitcoin blockchain, but it has not been built for that. It has been built primarily for digital cash. Now, when people saw that smart contracts is an interesting concept, they thought, well, let's build technology that is specifically built for the smart contracts. And Ethereum is one of these first developments. Ethereum was invented in the idea stage somewhere around 2013, 2014, and the first release of Ethereum happened in 2015. And Ethereum was built also as a digital token. So the digital token on Ethereum is called Ether, which can also be used for payments, but Ethereum has a lot of other capabilities. Ethereum has actually been built as a decentral computer, or also called the Ethereum virtual machine. And that's because when you execute code on the blockchain, it's exactly as immutable as the transactions that you store in that blockchain. So when you execute a piece of code and it's written into the blockchain, then it's not possible to alter that or to change that by any third party, except the person who has the private keys to that transaction. And that's what's making this really, really powerful. And then besides Ethereum, there's also lots of other blockchains, and some of those have very specific use cases, and some of those are also more general, just like Ethereum. But today, throughout the presentation, we will be assuming that the smart contracts that we're looking at are being run on the Ethereum blockchain. One of the reasons is also that it's currently one of the most popular ones. If we are looking at the market capitalization of the 4 largest blockchains, and we see that Bitcoin is still by far the biggest one, with around about $39 billion US market cap, and Ethereum currently is at 20 billion market cap. And this is also a signal for liquidity, which means that there's a lot of transactions going on, and at the same time it's a signal for demand, that people are also speculating, but also using it for real applications. And then besides these 4, there's over 700 other digital currencies and coins that are using the concept of blockchain, and that have either other specific use cases. Sometimes they are just pure copies of Bitcoin or Ethereum with very small changes. But generally there is a lot of innovation in the space. But since Ethereum as the platform for smart contracts that is definitely the most popular today, this is what we will be looking at throughout the presentation. One thing that I would like to mention before we move on to applications and to smart contracts is that the concept of blockchain and the token, the intrinsic token on a blockchain, is something that is very closely linked to each other. Sometimes you would be reading that some private companies or consortiums are running so-called private blockchains. And these, in my view, are not real blockchains. These are just distributed databases where maybe 5 or 10 or 20 entities agree on a shared database. But if you want to have a really immutable, decentral ledger, then you need to have hundreds or even thousands of copies, just like we have seen in the example of Bitcoin, where there is over 7,000 nodes, and actually Ethereum today has over 10,000 nodes. So changing that history in that blockchain is nearly impossible. If you have just a consortium of 5, 20, then it's actually really easy to have collusion and to change the history. But if you have a public blockchain, there has to be an incentive for somebody to run it, who is actually not affiliated with all the people who are running applications on top of it. And so that there is an incentive to actually run these public blockchains, the tokens that are on those blockchains have monetary value. And that's because when you run a transaction, sometimes, not sometimes, but somebody needs to write that transaction into the blockchain. And of course, nobody would be doing that if there wasn't a financial reward for it. And that's exactly what the tokens are. They're the financial reward for those people who are writing transactions into the blockchain. And that's something that's really important to keep in mind when you read about blockchains, private blockchains. In my view, they are not real blockchains because they just have a relatively small number of copies of them. If you look at the types of applications that are possible based on blockchain technology, I typically tend to categorize them into 6 categories. Everything starts with payments normally, because as Bitcoin has been invented as a digital currency and payment network, then the first use cases were in remittances, where people are sending money across borders at very low cost and really fast. Also at Bitbond, we primarily use the payment function of Bitcoin in order to send money efficiently across borders. We're basically replacing the SWIFT system, which is relatively slow and expensive, with Bitcoin, because it's a lot faster and cheaper. And so these are relatively payment-related applications. Then also there is speculation, where people simply speculate on the price of coins. And then you've got immutable registries, where people simply use blockchains as a database where they know that the data that they write into that database cannot be changed. And then there is smart contracts, which is what we are going to talk about now. And smart contracts are basically pieces of code that are executed on the blockchain. So now let's jump into the basics of smart contracts and what they actually are. Now let's start with traditional contracts first. If you make a traditional contract, let's say you make a bet on the weather. So there's a couple of people, they meet and they say, well, tomorrow it will be 20 degrees, tomorrow it will be 25 degrees. There's a lot of room for disagreement. When they meet again tomorrow, there can be disagreement about what they actually claim, what the temperature is going to be. They can disagree on the actual payouts. And in order to solve that, people have developed mechanics in order to cope with these types of problems. And typically these are written contracts. And if there is a contract that has a relatively high value attached to it, then in many cases contracts are also notarized, which means that you go to a trusted third party, and they will be a witness to the fact that there was a contract between 2 or several parties. And this is basically just to make sure that the disagreement about a contract will be limited to the highest degree possible. However, there can also be problems with that. You can lose the documents. The documents can get lost for several reasons. There can be fraud involved. Often notaries also take money into an escrow account. This money can be embezzled. So there's a lot of points of failure and a lot of things that can go wrong in this traditional sense. And then also there's the aspect of cost. If you make an M&A transaction, for example, and you want to have that notarized, then you will see that there's actually a relatively high percentage of the deal value in cost for the notary. And this can be really significant also in real estate transactions. If you ever were involved in a real estate transaction, you will know that notary costs can be really high. So that could be another motivation to use alternative technologies in order to drive the cost down. Now, how can you do that? Let's assume you run a smart contract. On the left-hand side, this is a code example of an actual smart contract. The good thing is that if you put the contract into the blockchain, you know it cannot be changed anymore. And therefore, you reduce the risk of fraud, of altering a contract after the fact. You can even use escrow accounts on blockchains, so you basically reduce the risk that money gets lost that is involved in those transactions. So those are the general motivations why you would be running that. One thing is important to keep in mind though. In contracts that you want to write into the blockchain, you need to have quantifiable circumstances. So the outside temperature, for example, is a quantifiable circumstance, so we can make a contract about that. The stock price of BMW, something that is quantified where you can observe the price. So there are many circumstances that are quantifiable, and those circumstances and those types of contracts are very well suited for a smart contract on the blockchain. If you have a contract where there is qualitative assessment necessary, then those types of contracts are not so well suited for smart contracts on the blockchain. To give you an example, imagine you want to sell t-shirts and you ordered 1,000 yellow-colored t-shirts from a supplier because you want to sell them. And now the supplier delivers the t-shirts and you find out that it's actually not the exact color tone of yellow that you ordered. But the supplier will say, well, that's exactly what you wanted, but you will say, no, that's a different color tone. Then it's something that's not so easily quantifiable and something that's not so easy to write into the blockchain. So these are kind of problems that blockchains cannot solve. It's not like it's a tool that can solve all the problems in the world, right? It can solve problems with quantifiable contracts where things are relatively clear and put into numbers. One thing that's very important to differentiate in terms of terminology is something that's called smart contract code and smart legal contracts. Smart contract code is something that is actually just a program that's running on a blockchain. And it's a little bit unfortunate that the term smart contract is also related to that. It's because it's actually just a piece of software that's running on a decentral computer. And this does not necessarily have to involve multiple parties. This could just be a computation where you want to make sure that it actually happens. Let's say you want to make a weather forecast. That's something that typically involves a lot of computational resources. And you want to make sure that this weather forecast will definitely be computed no matter what. Then you could make that run on the Ethereum virtual machine, and it will definitely happen unless you, the contract owner, will stop it. And this doesn't involve any other third parties. This typically wouldn't involve any disagreement, but it would be a program that would also be called a smart contract. But it's not a legal contract between different parties. It's simply a piece of code that's running on the blockchain, and that's immutable. In contrast to that, we have smart legal contracts, and they are actual contracts where multiple parties agree on something, like this weather bet that I mentioned previously. And this is something where the blockchain can actually help solve problems of disagreement. Now, let's stick with this weather example. Let's say you want to make a bet between two people, and one person says tomorrow the temperature will be above 20 degrees, and the other person says no, this is not going to happen. And if you write that bet into the blockchain, the moment the bets are off, the people who are participating in that contract will send money to a contract address, and from that point on, there is no risk for the parties involved in that contract, because the money is sitting in an escrow type of account. They know that no other party has access to it until the contract settles. And so let's say you have an expiry of that contract tomorrow 1 p.m. Then nothing and nobody can change that contract until 1 p.m. tomorrow, and the contract will automatically pay out the amount of money to the winner of that contract. And the great thing is that you don't need to trust any third parties, because it's already on the blockchain. It's stored on thousands of copies of the decentral database, and you know that if you win, if you made the right bet, you said the temperature will be about 20 degrees, and it actually was above 20 degrees, then you will get your payout. Now, there's one thing involved here that is called an oracle, because the contract needs to learn about the outside temperature from somewhere. The blockchain obviously doesn't know about outside events that are happening outside of the blockchain. And therefore, people came up with a concept called the oracle. And the oracle is like a connection to outside data sources. And there's multiple oracles. If you're a programmer, you could set up your own oracle. One pretty popular oracle for the Ethereum blockchain is called Oracleized. And that lets you connect smart contracts to external data sources. And this could be simple websites or URLs. This could be data providers like Wolfram Alpha, which has a public API. And you could use Wolfram Alpha, for example, as a source for the temperature in Berlin. If you go to wolframalpha.com, you type in temperature in Berlin, it will give you a result, it will tell you what's the temperature, and you could use exactly that result through the oracle for your smart contract. So you need to have a connection to the outside world if you want to refer to data that's happening outside. Now, one thing that you need as a user if you want to interact with smart contracts is browsers or browser plugins. These are three relatively popular browser plugins. One is called Parity, the other is MetaMask, and the third is Mist. And they are basically building a bridge between your normal browser that you are using every day, your Chrome, your Firefox, or whatever you're using, and the blockchain. And if you want to interact with a smart contract as a user, I'm not talking as a programmer, as a user, then you will need one of these three, or there are some others as well, but you will need such a browser plugin. And then what you can do, and I really encourage you to do that, there's a website called dapps.ethercasts.com. Dapps, by the way, stands for Decentral Applications, which is also another word, another term for smart contracts. And you can simply go there and test out some of the smart contracts that are already live. And this is not the only directory of these smart contracts, there's multiple others, but this is one that you could get started with. So you first would need a browser plugin, and then you need to go to any smart contract that you find interesting and test it out. Now, if you wanted to set up your own smart contract, there's a relatively lightweight way to do that. You can go to Dealmate. It's a website which has a relatively simple user interface where you can put in the conditions of a contract, and this weather bet that I just described is something that this website Dealmate would be capable of doing. So you could put in all the parameters, and it would basically write the code for that smart contract for you. And this is really convenient because if you don't want to program the smart contract yourself, this interface to the Ethereum blockchain will actually do that for you. Now, if you want to go one step further and actually program the smart contracts yourself, then you would need to make yourself familiar with a programming language that you can use on the Ethereum blockchain. Solidity is the programming language that's probably the most popular today for programming Ethereum-based smart contracts. And once you've done that, you will need an integrated development environment like Remix or Truffle, and that will let you actually compile the code and deploy it to the blockchain. The good thing is that there are already these IDEs, so people who are programming already, and especially people who are familiar with JavaScript, could relatively easily get started with these technologies. So this is basically how to get started. And before we look at some applications that already exist today, I just would want to highlight when and in what cases smart contracts actually make sense. Because sometimes they are a great tool in order to build applications and in order to build legal contracts, and sometimes they are not so feasible for that. And one thing that's to consider is that when you have adverse interests, so in the bet example, everybody wants to get the money out of the pot, obviously, right? And therefore you have adverse interests, and in that case it makes sense to use a smart contract. Also, when you want to avoid central points of failure, so let's assume that you have just one server which is storing some contract information. And if this server gets compromised, or if simply due to a technical failure, the data from that server and from that database gets lost, then you might have a problem if contract data is stored there. And that's also one other case where smart contracts are really, really useful, just because they are stored in thousands of copies of the decentralized database, the blockchain, and therefore the probability that you will suffer a data loss is really, really small. And then also one thing that's, of course, quite important is the cost. So if you have solutions that are already working well for you and that are nearly cost-free, then you might not want to consider smart contracts. But if you are using solutions to enforce contracts and to make sure that contracts are binding like a notary, then smart contracts might be a really good solution for you, just because, as we've seen with this DealMate, for example, or with the ease of access to programming on smart contracts, it's really, really low cost, and you can actually circumvent the notary in some cases if all parties agree. There's a question.
Because we're talking about the cost, another question. Going back to the example of the bed and the weather, until the size of the event, I have had assets in the cover because I have to pay them off €5 for my bed. In order to win, I might get back €10, but until the event of the, which is the size of the contract, through that assets, I can't use it anymore.
It depends on how you design the contract. So typically you would want to have that money in an escrow account, right? You could also design the contract that it doesn't require to pay up front, right? But then you run into counterparty risk. But the designer of the contract can design it in any way they want, right? So that's not something that is sort of predefined by the way smart contracts work. Everything that basically can be described in a clear way in code can be done, right? So it's not a requirement. It's basically a design decision of the contract. Good, so let's look at some smart contracts / distributed and decentral applications. Because as I said at the beginning, we should be differentiating these terms a little bit. Sometimes you have a smart legal contract, which involves multiple parties. And sometimes you just have smart contract code, which effectively is a decentral application that runs on a blockchain. Now, the first thing that is worth mentioning are tokens or ICOs, which are called initial coin offerings. It's something that has become very, very popular over the roughly one and a half last years. And these are actually not smart legal contracts, but these are typically decentral applications. Now, what are they? So if you want to raise equity for a project or for your company, typically you would go to a venture capitalist, or if you're a bigger company, you might consider going public with your company and raise funds from the public markets. Now, these types of fundraisings are not really accessible to smaller entities or to startups, especially public markets are something that's really, really expensive to access. Now, what some companies are doing, and some do it really successfully, they issue tokens that represent ownership in their company. So effectively, it's like a stock. And what they do is they issue something like a covered coin on the Ethereum blockchain, for example, and then that token represents a share in their company. And then people who believe in the project or in the company can buy them, and it's basically working like a stock exchange with the advantage that the access barriers are really, really low, because everybody with a computer and some programming knowledge can start that. And therefore there's also a lot of competition in this space, but also a lot of innovation, which is something that I find really, really interesting. So raising funds through that method is something that a lot of people started to do. And then basically you have like a piece of equity in that company that's represented by a token. But also the tokens could represent other things. So this could be other assets. At Bitbond, we're about to launch a token that will represent a diversified portfolio of loans. So the token can basically represent any kind of asset. It could also be a piece of land. It could be a title to something. So it could represent a lot of things. Yeah, there's another question.
What is the difference between crowdfunding and an ICO? Because it looks very similar.
It is effectively very similar, right? An ICO is basically a crowd-funded fundraising company.
But why is it so much more successful than any crowdfunding campaigns?
I think because it's really, really accessible. So if you want to participate in crowdfunding in Germany it's relatively highly regulated, and you need to sign up with some crowdfunding platform, you need to open an account there, and if you're already familiar, at least to a certain degree with digital currencies, then you can participate in the token sale from anywhere in the world, and the barrier to participate as an investor in that is really low. So as a company, you're accessing a global capital market, while if you do a fairly traditional crowdfunding campaign in Germany or in any other country, then typically you would only access potential investors from that country. So from the nature of the fundraising, it's relatively similar. However, the access is a lot easier and you're potentially accessing a lot more investors.
How do you market your company on a?
It's up to the company that's running it. I mean, you can basically use any online marketing channels that you want. That's up to you.
If you look at the platform that offers ICOs, you would see 90% of the companies are related to blockchain technology, issuing their own coins or whatever. But that too would also apply for, let's say, any brick and mortar company?
Of course, everybody who wants. Okay, yes, sure. Sorry, yeah. So the question was that right now, most of the ICOs that are run by blockchain companies, which is true. And the question was, could any brick and mortar business, for example, also run an ICO? Yes, of course. The reason why we see so many ICOs of companies that are from within the blockchain space is that they are familiar with the technology, right? But actually, to run an ICO from a programming perspective is not that difficult. Like, everybody who has some fairly decent programming knowledge could set up a token. There's a lot of open source code that you can reuse and that you can customize for your own purposes. So I believe that ICOs is something that in 2 or 3 years from now will be accessed by many different types of companies that are not really related to blockchain types of projects.
So I was just trying to understand this kind of switch, the legal aspect of having a ICO with a bricks and mortar company where you have, let's say, a GmbH, like a German corporation, and that has certain regulations to it that are pretty strict actually, and how you can't, like, how do you offer those shares? In other words, the GmbH is not really part of your smart contract, or is it?
Yeah, so the question here is, if you are a German GmbH, so a German private limited company, and you want to run an ICO, then you would basically need to transfer those shares into the tokens. And it's something that I agree is a legal challenge, and a lot of the ICOs that have been running in other jurisdictions because of these legal issues that might come up. And in many cases in jurisdictions that have a relatively low financial regulation. So in my view, but this is really just my personal view, if you ran an ICO in Germany where you actually put up real company shares and sell them through the tokens, then you would probably have to comply with securities law. But this is really just my personal assessment, and I'm not a legal expert, but many things are really, really similar to traditional securities. However, the reason to still do it is that you can potentially access a lot more investors, and you already have a secondary market. So people can trade your coins from day one, and that's something that's a real advantage, even if you have the same legal requirements to this ICO as if you were selling shares in a real public regulated market. There are quite a few questions coming up now. I would suggest we go through the rest of the applications. I think there are 6 or 7 more slides, and we will still have time for questions after the presentation. So if it's okay with you, I would continue for about, I don't know, about 10 more minutes, and then we can open up to everybody for questions. So let's move on to another type of application, which is called notar.io, and this is basically a replacement of a notary service. What this service will do is it will let you upload any type of document. This could be a contract, this could be an image, this could be any type of file that you have stored on your computer, and what it will do, it will create a hash out of it. And the hash is basically a string of characters that is unique for the document that you uploaded. And if you, let's say you take a PDF, which has a written, pretty standard contract on that PDF. Now, if you change that PDF, if you just remove 1 comma from there, if you hash it again, so you again create a string of characters that's representing that file, the hash will definitely change. And so if you have a contract that was written at some point and you scanned it into a PDF and then you upload the hash into the blockchain, you will always have a proof that you owned this file at a certain point in time when the timestamp was made. And that's exactly what Notar.io is doing. So it's a user interface on the internet where you can upload documents that will be hashed and then written into the blockchain. And the great advantage is that only the hash is stored in the blockchain, not the actual document. So no third party will have access to the document, but only to the hash. So it will let you prove that you, at a certain point in time, were the owner of that document. And it can replace notary services in some areas. One other application, and this is actually one very early application for blockchains in general, is fair gambling. When you gamble on this website eToro, then you can review the smart contract, how it's actually generating the roll of the dice. So you can review and make sure that it's actually a fair game. And then you can play. I personally don't gamble a lot, but it's something that's really interesting. And when you consider that financial derivatives in many cases function very similarly to games of chance, then you can easily imagine that you could also make derivatives contracts that typically are contingent on stock prices, on commodities prices, on FX prices, and you could have immutable derivatives contracts and have them written into the blockchain. And a lot of derivatives contracts actually are done over the counter, as it's called, so directly between banks or between investment funds, between hedge funds. And sometimes there are disagreements about the nature of those contracts. If they were done as smart legal contracts on the blockchain, then the room for potential disagreement would be really, really limited. Because the good thing about gambling or about derivatives contracts is that they are normally contingent on quantifiable data, like stock prices, commodities prices, and all that. So this is something where, even though gambling might look like a not so fancy application, if you transfer that concept into the financial world, then suddenly you start seeing a pretty big market that there could be. Now, one other thing is transfer of ownership through or without escrow. So if you transfer property, for example, in many cases you will have money in an escrow account with a notary, because you want to make sure that if you are selling something, that the buyer has actually the money to pay the price. And if you're buying, you want to make sure that when you pay, the ownership of the property is actually transferred to you immediately. And therefore you will, in most cases, use a notary, and you will use the escrow service of a notary. And that, as I said earlier, is quite expensive. And you could do the same thing over the blockchain. If the title to a piece of land, a piece of property, was in the blockchain, then you could set up an escrow account on the blockchain, and when you make the payment, then in that very moment, the ownership will be transferred to you. And therefore you can also eliminate the notary in the cases where you actually need an escrow account. Now, smart locks is another very interesting application. And there are smart locks already today, but the problem is that typically the access to these locks is controlled by a central service. And the bigger the smart lock industry becomes, the more incentive there is for hackers to trying to get access to these central servers in order to open doors that they actually should not open and shouldn't have access to. So right now this problem might not be so prevalent, but the bigger and the more popular smart locks become, the more incentive there is actually to try to hack them. And if these keys were stored in, for example, a multi-sig way via blockchains, then you could limit the risk to actually get robbed in your house or in your warehouse. And therefore this is another great application where you can control access to certain houses or to property via the blockchain. Another application, also something that we are looking at Bitbond, is collateral in loan contracts. So typically when you have bigger loans, you want the borrower to put up collateral as a security in that loan. And what we're looking at is, for example, if you want to finance something, typically a car is something that serves very well as collateral, because there's a big active market for used cars. So if the borrower defaults on a loan and you were the lender, then you would liquidate the car, basically sell it to somebody else in order to make up for the loss from the loan. And today this is something that's a relatively traditional way to do that, because you would have a title to the car and you would actually have the physical paper and you would have it stored. And if you wanted to sell the car, you would actually need to be present at the sale transaction. Now, if the keys to the car were digital, they could be controlled by the blockchain, and they could even be dependent on the payments that the borrower is making. So the key to the car would only be active as long as the borrower is actually making their payments on the loan. And once they stop making their payments and default to the loan at some point, then you could also revoke access to the car via those digital keys to the borrower, and you could liquidate and sell the car without actually being physically present. And that's something that we're looking at. As you can imagine, there is a connection to the actual hardware, so it's not something that's so easy to implement compared to things that are only existing in code and that are pure software. So in such a case, you really need the involvement of, for example, the car producer. So it's a project that is a little bit more complex, but it's also a project that potentially can become really big, because collateral in loans is something that's very frequently used, and if you can make the process more efficient, and there's a lot of parties that would be interested in that. Another, and I think this is the last application that we're looking at now in the presentation, is when you have audit trails. So let's assume that you have physical objects, or again, property, houses, flats, warehouses, that have a history of repairments, that have a history of ownership. Typically, these things are hard to track, and sometimes they get altered after the fact, because somebody wants to claim that something has been repaired in a year, but it actually hasn't. And if this information only exists on paper, then it's actually relatively easy to make fraudulent activities. But if you have that information stored in the blockchain, for example, using the service notar.io that I showed earlier, then you can have an audit trail that's immutable, and it will make sure that the information that is there is actually true. That is another application. And then beyond these that I just presented, there's a lot of others that we're not going to cover today, but maybe we can talk about it later in the questions or in the discussion. You can have fair voting. I mentioned financial derivatives already. You can have distributed computing. This is something like the weather forecast that I mentioned. You could even use it as distributed file storage, if you really wanted to make sure that certain digital files will always exist and cannot be destroyed. So there's a big range of other applications that we don't have time to discuss today, but I just encourage you to go and look at the stuff that might be interesting for what you are doing, for what you are interested in. And typically, since the evolution of blockchain has already progressed quite far, and there's a lot of innovation going on, nearly everybody would find something that's interesting for them. So to summarize, one thing that's important to remember is that smart contracts are basically immutable applications. So they are pieces of code that can run on a blockchain and that are immutable. And the second thing that's really important is that you can have legal contracts that will help you make nearly trustless agreements with each other. And then the third thing is, I want to encourage you, as I said, to go and test it out. Right? It's not so hard to get started to install a browser plugin, and blockchain sounds like a very theoretical and complex subject, but when you start using it, it's actually not that hard. So thanks a lot, and I would say we can open up for questions now.
If I would do the same thing with a digital object, for example,
So it might be that there is something like that, but I'm not aware of it. By the way, the question was if you have a digital asset. So in the case of a car, it's relatively simple. Either you can start the car with a key or you can. When you have a digital asset, like an image, for example, then once you've had access to it, or an MP3 file, then you can copy it. And I'm not aware of examples where you basically split the asset, but I'm aware of an example where people are trading cards, digital cards that have an image on them, and prove the ownership through the blockchain. And now, of course, you can take a screenshot of that card and make infinite copies of that image, right? You can do that. But if you want to sell it, you have to prove that you're the actual owner. And it's interestingly enough, there are markets for the original card where only the owner would sell it. Even though the screenshot that you take from that image has the exact same quality, it has the same resolution, everything is the same, right? But there are real markets for these cards where you would only purchase it from the actual owner. So it really depends on how people attribute value to digital assets, I would say. Because if they attribute value to the original file, then there will be a market price for it. If they don't, if they are fine with a copy where they know they are not the original owner, then probably there won't be a market for that. But maybe one last remark about that. If you make illegal copies of videos, right, then you can actually be held liable for that, right? But how would you prove that you actually acquired a video film and paid for it? Well, if you don't have a receipt or anything, then actually you could get into trouble, right? And in that case, it would actually be useful if you could digitally prove that you paid for the song, for the video, for the image, for whatever, right? So there might actually be a use case for that. Could blockchain be the end of piracy? I'm not sure, to be honest. I'm not sure. Because if you have digital assets like films, like music, I think it will always be really easy to copy that. And it's more of a question of how good will be the enforcement of those rights. Blockchain could theoretically be the tool that could help end piracy, but will it really do that? I'm a bit skeptical.
Bitcoin, for example, like on dogs and so on. Why should anyone trust the system where you can steal any kind of blockchain money so easily without being found?
So the question is, why should you trust basically a payment network or an asset ledger where it's relatively easy to steal that?
Not easy, but you can find
And it's hard to trace, yes. Okay, and it's hard to trace. Well, first of all, if you compare it to a bank robbery, right? If somebody robs a bank, they take out cash and then run away with it. Then it's also relatively hard to trace, and people still use banks and bring cash to a bank. And I would say it's relatively similar here. And in some instances, it's really, really hard to trace those people who illegitimately acquired some assets, but sometimes it's actually possible to follow the money, just because the blockchain is a public ledger, and you can watch where the transactions are going. And if you have lost a lot of money, it might actually be worth doing exactly that. And at some point, somebody will want to exchange those bitcoins, those ether, those litecoins into fiat, into euros, pounds, dollars, whatever. And at that point, they will need to identify themselves with the exchange. And that's the point where you have a certain chance of actually identifying the people who legitimately acquired those assets. So it is hard to trace, but it's also to a certain degree a question of cost. And if a lot of assets are involved, then you'd also be willing to pay more to trace down the robbers. So it really depends on basically what is at risk. And it's the same with a bank. You are willing to take some risk, But if you have a lot of money, you will not store all the money just with one bank, but you will typically distribute it. And it's the same what you would do in the digital world. If you have a lot of Bitcoin, a lot of Ether to store, at least I wouldn't just store it with one exchange. I would probably use something that's called cold storage, where you actually don't trust any third parties, but you just hold the keys yourself. Or if you want to use third-party services, then you would typically distribute it across many different ones and not just store your assets with just one exchange. Follow up? It's your decision. It's your decision how you store it. And if you own Bitcoin or if you own Ether, it's basically a combination of a public and a private key. It's just two strings of characters. And it's your decision whether you trust a third party with those keys or whether you want to store it yourself. It's your decision. It's exactly like if you own gold. Do you bring that gold somewhere and trust a third party with it? Or do you put it in your basement and make sure that nobody gets access to it?
If you code for every transaction is public on the blockchain, because it's a distributed database, how much privacy risk is there? So if we rent our cars, lock our homes, have all our personal transactions on a public database, how big is the risk to lose my privacy?
I think it depends on how those transactions are designed. When we look at the example with Notar.io, where you make sure that you can prove that you own a document at a certain point of time, but the actual document is not stored on the blockchain, then I don't think that there is a privacy risk involved. If you store actual clear data on the blockchain, then obviously make it accessible to everybody who wants to read it, right? So I think it's mainly a question of design.
So there's a growing numbers of ICOs. Tezos, the biggest one today, just finished today. And probably it's just starting, it's just getting bigger. But they have very negative effects on blockchain speed and also on the currencies, as they are not cashing out with fiat. What's your opinion on that?
So there's two aspects. One aspect is that, So the question is that many ICOs are causing two kinds of problems. One is that since a lot of people are participating in those ICOs, there's a lot of transactions happening on the Ethereum blockchain, on the Bitcoin blockchain in a very short amount of time. And one thing that to consider is that the amount of transactions that can be done within a certain time, like within 1 second, within 1 minute, is limited. And this is something that's still sort of an evolutionary process where there are different approaches how to make the number of transactions that can be done more scalable. And the ICOs sometimes are so successful that so many people are doing transactions that other transactions don't come through. So that's one problem. And then there's another problem is that when people make a lot of money, so when the price of a token went up and they want to cash out, that they drag down the price. And the question was, how do we see that? I think the first problem needs to be solved because transactions on blockchains need to be more scalable and we need to be able to accommodate more transactions. In the case of Bitcoin, you can currently run 7 transactions per second on the network, and that's the maximum. And I think that's actually a relatively low number. If you look at Visa or MasterCard, they can accommodate, I think, up to 100,000 transactions per second at peak times. So Bitcoin is far, far away from that. And if we want Bitcoin to become a global payment network that's used by millions of people, then it has to be more scalable. And the same applies to Ethereum. So this is something that I think has to be solved, but I'm also really confident that it will be solved. I like to compare that with internet videos. Before YouTube became big, there were a lot of other startups that wanted to provide a similar service like YouTube. And no VCs wanted to fund it because they said, nobody's going to use that. The bandwidth of the internet is way too small, and nobody will be able to watch videos online because the bandwidth is simply not sufficient. And if you compare that situation to today, where I think roughly 30 or 40% of internet traffic is just Netflix, and people watch videos all the time, then clearly that problem has been solved. But back then it looked like a huge, huge scalability problem of the internet. And I think we're in a relatively similar situation with blockchains today. It looks like it has a really, really bad scalability problem, and it actually does, but I'm also confident that it will be solved because the advantages of running transactions on blockchains are so big that there is enough incentive to actually solve that problem. The second problem, sorry, this is a very long answer to a short question. I promise I will be short on the other questions. The second problem that you mentioned, that the people who are cashing out are driving down the prices of digital currencies, I don't think that's a problem at all, to be honest, because wherever there is volatility, there is opportunity for other traders, and I just think that as the ecosystem grows, there will be more and more transactions and the volatility will go down. There will be always people who have opposing views on where the price is going to go, and I think this is a problem that will, in a relatively short amount of time, solve itself.